Hello, my name is Denise Williams, and today I'm going to discuss a word problem that has to do with the normal distribution. So let's get started. I'm going to go over to my whiteboard. You'll follow me there, where the problem is already listed. So the problem is a 2003 study found that medical residents' mean number of hours worked in a week is 81.7. Suppose the number of hours worked per week by medical residents is approximately normally distributed with a standard deviation of 6.9 hours. What is the probability that a randomly selected medical resident works more than 100 hours in a week? Now we're going to do this problem using the normal distribution table. So that means that we're going to have to use a few formulas and we're going to draw a few pictures. So we're going to start off by first writing down all the information that's given in the problem. We know that the mean is equal to 81.7 and we know the standard deviation is equal to 6.9. We're also going to go ahead and write out what we're trying to find. Now the problem is asking us for the probability that one resident works than symbol. Now what is not essential but what is advised for you to do is to go ahead and draw out the normal curve, labeling the mean, and the area that we're trying to find. So we know that we're trying to find the area to the left of 100. So I'm going to go ahead and shade that. Now this is the normal, the normal values. And now we're going to add an extra line that represents a standard normal. Now the standard normal means that the mean is going to be 0. We also have to convert this 100 using the z-score formula. So we're going to go ahead and use z equals x minus mu over sigma. And we're going to plug in the values that we already have in the problem. So we have 100 for the x, and that comes from this here. And then we have the mu of 81.7 that's written on the board. And we have 6.9 for the standard deviation. Now when we solve that, we get 2.65. 2.65. So what does this all mean? Now this means that we're taking the probability of x greater than 100. But in order to use the standard normal distribution table, we have to convert that to a z-score. And when we converted it to a z-score, it's equivalent to saying the probability that z is greater than 2.65. So what is the probability that z is greater than 2.65? We're going to go over to our next page where I have uploaded a copy of the standard normal distribution table. And we're going to go ahead and find 2.65 on this table. Now 2.65 needs to be broken down into two parts. We're going to take the number that's in front of the decimal and behind the decimal, and then we're going to take the second number behind the decimal. So this is equal to the 2.6 row that we're going to look in, and the 0.05, the 0.05 column. So here's a 0.05 column, and we're going to scroll down, just scroll down a little, till we get to the 2.6 row, which is right here. So the 2.6 row and the 0.05 column, where does that overlap? It overlaps right here at 0.9960. So what does this mean? This particular table, if you look at the top, you'll see that the area to the left of z is shaded. The area to the left of z is shaded. So what this table is telling me is that the probability that z is less than 2.65 is equal to 0.9960. But remember that we want the probability that z is greater than 2.65. Now what is that equal to? All we have to do is subtract 1 minus the area to the left will give us the area to the right. So the area to the left is equal to 0.0040. Now we put that all back into what we were talking about, the probability of x greater than 100. Remember, that's what we were trying to find, is equal to the probability that z is greater than 2.65, which is equal to 0.0040. And this is our final answer. So this is it for this particular problem. If you have any other questions, please come back and see me.